Welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're going to be focused on integration testing. So last week we looked at unit testing, which was testing small bytes or chunks of our application, so things like an individual function. But this week we're going to be looking at integration testing, which is looking at integrating multiple pieces together into one system and then testing that system. So this is going to allow us to test code that we use for things like a sign-up process or anything that involves multiple steps involving different parts of our application being called together at once. So what we're going to do is use Jest again for this. We're going to write our tests in Jest, and we're also going to run our tests with Jest. So we're going to go through the process of looking at an integration test that I already wrote before I filmed the tutorial, just because it was a little bit easier and it was more economical in terms of saving us some time so we don't have a 2-hour tutorial in front of us. But what we're going to do is look at what code I wrote, and we'll step through it step by step to see, okay, this is why this was added here, this is how it's added, and look at how all the different pieces are wired together. Alrighty folks, before we get started writing our integration test today, I want to remind you to check out PUP over at cleverbeagle.com/pup. And PUP is the boilerplate application that we use with mentees at Clever Beagle, and it ships with all sorts of neat features to help you build your own product, including everything you're going to need to write your own integration tests in your application. So if you head over to cleverbeagle.com/pup, clone a copy, and also make sure to check out the documentation. There's a lot of detail on writing integration tests and running integration tests for your own product. When it comes to integration testing, what we need to keep in mind is that the word integration is very important because it's telling us what we're testing. We're saying, do multiple pieces of our application integrate well together? So we're testing the integration of a number of different parts. So like we saw in the previous Feature Friday on unit testing, what we were doing is testing one small unit, so an isolated piece of code that didn't really have any other code related to it. We were testing a single function, or in the case of that tutorial, a single date function being exported from a module. So the difference between that and an integration test is that an integration test is saying, okay, those unit tests are great, but what happens when we combine a bunch of those functions that may have unit tests for themselves? What happens when we combine all of those functions together into one chunk of code and try and run them all at the same time? Do they work well together? And there's a lot of different reasons you're going to want to do integration testing. So most typically what I've found is that your integration tests are for what I refer to as multi-step processes, or in PUP we use the term action. So an action is something like a user signing up for your application. Typically that's going to involve more than just creating their account in your database. It's going to involve things like, well, we might need to create their account, and then we're going to need to set some roles on that user, and then we might want to add them to a mailing list on a service like MailChimp. Maybe we want to update a CRM, and all of these different steps that are discrete steps, but we couple them together into one process or one action that we can call at once. So when somebody submits the sign-up form on our site, we call a single action, and then that action performs all of those steps for us. And so when it comes to writing tests for that code, we need to write an integration test because we want to see, okay, if we call one function or one action that groups together a bunch of different functions, does that action fire in the way that we expect, and does it behave in the way that we expect? To demonstrate integration testing in PUP, what we're going to do is focus on adding an integration test for the update user action inside of PUP. So this is the action that gets called in one of two ways. So this is either called when a user updates their own profile inside of PUP. So if they navigate to the /profile route, maybe they change their name or their password or something like that and hit submit, that is responsible for calling this action. And so is the admin panel. So when an administrator is editing or managing a user and they want to make an update to that user, that also makes a call to this action. So what we want to do is make sure that this action is behaving in the way that we expect. And we can see here that we've got a bunch of different functions grouped together. And that's the basis of an action inside of PUP. So an action is it's a pattern that's specific to PUP. That was something that I had created after several years of being frustrated with having these chunks of code that perform multiple steps and they were related, but it was really hard to test them and it was really hard to make sure that they were behaving consistently. So this pattern, there's not much to it. All it's doing is it's saying export a function from a file, and that function is calling to other functions. That's not the grand tour of what an action is, but that's the high level concept that's at play here. Is we're saying take one function to wrap a bunch of other functions and call them in sequence. So we can see here that we've got update user as a function, and update user does a few different things, and each of those things, if we look, it's just one line. So we're saying update user password, isAdmin, update user email. All of these functions, if we look further up in the file, these are all functions defined in here for the most part. So the only one that's not is isAdmin, and we're going to see how that comes into play in a little bit here. But the idea behind an action is that we have single functions grouped together in a file, and we'll notice that there's a pattern here of we take a function and inside of it we define a try-catch block, and that try-catch block says I'm going to run some code, and this is the code that's performing that given step. So when we talk about a step, we mean one thing as a part of the action. So in this case, updating a user might update a user's settings, it might update their profile, it might update their email, it might update the roles. All of those are discrete steps, but they're all potentially going to need to be fired at once. And so that's the purpose of an action. And so if we look at this function, we say, okay, in this case, we're running meteor.users.update. And by putting this inside of a try-catch block, what we're doing is we're isolating that code. So if for some reason this code failed, or maybe we passed the wrong parameters to it, when it fails, the catch here is going to tell us exactly where that failure occurred relative to the action that it's occurring in. So we can see we put a little text in front of the error message. So we say this is happening in the update user action, and specifically the update user settings function inside of that action. So in order to test this action, what we need to do is call the action by itself, passing it some parameters that we think are going to call some sort of functionality inside of the action, and then verify that those functions were actually called. So if we jump over here, you can see I've already wired up all of the tests that we're going to write today. So we're not really going to write them in real time, primarily because integration testing is one of those things that involves a fair amount of thinking, and you only really get into a flow with it or get to a certain speed with it when you're doing it for at least, I've found somewhere in the range of maybe 20 to 30 minutes during the course of your workday, up to even a few hours, depending on your level of experience with integration testing. So to make sure that this Feature Friday isn't 2 hours long, I figured, you know what, it would be best if we just go ahead and step through what I've written already, so that way you can still understand what's happening, but we don't have to wait for me to kind of muck through the code as we're building out our tests. There's a few hallmarks here that I want to point out before we get into the meat of our tests. So if you haven't watched the Feature Friday from last week on unit testing, make sure to jump over there. I just posted a link up in the corner, so if you haven't watched that yet, give that a watch first before you dig into this integration testing. But if you did watch last week's Feature Friday, you'll remember that all of the testing, or I should say the unit tests and integration tests inside of PUP, are written and run using a framework called Jest. And Jest is a testing library and test runner built by Facebook. So it's a combination of those tools together in a really, really nice system. And when we're working with Jest, what we're going to do is always create a .test.js file near the file that we're testing. So in this case, and this applies to both unit tests and integration tests. So it doesn't matter the type of test that you're writing, because honestly, Jest doesn't really care. It's not aware of what you're testing. It just knows that that file contains some tests written using the syntax and the functionality of Jest. It doesn't really know that we're trying to write an integration test. So what we need to do is add a file with the name of the file that we're testing. So, and this is just for us. So we could call this pizza.test.js, and it could still test the update user function, but for the sake of sanity, it's best to say call it the exact name of the file .test.js. So we have update user.js and we have update user.test.js. And so inside of that file, what we can see here, again, I've already written out all of the tests, but if we focus just on things like this, so here I've got this function I'm calling called describe, and to it I pass a string. So this is saying we're creating or starting a test suite. And a test suite is a collection of tests that are related to one another. So in this case, we have multiple tests that we want to perform against the update user.js action. And so in this case, we're saying describe update user.js to say describe the testing for update user.js. And if we look inside, each of our tests are defined using another function conveniently called test. So when we call test, we pass the name of our test along with a function that's actually responsible for performing the test. So test is saying define the test, and the string just gives us a convenient name. So we'll see in a little bit when we run our test, that name will be printed to the console for us. And then this function is just running the test for us. So this is the actual test code or the meat of the test. And so if we look inside of the test, the other part we want to pay attention to are these expect functions. So we can see expect, 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 expect. And expect is what we're using to verify, or assert is the word that you'll hear when you're inside of testing circles. We're trying to assert that something is happening or some result is being returned to us. So in this case, we're saying we expect this function accounts.setPassword to have been called 1 times, and to have been called times is a function or a method that's given to us by Jest as a sub method on the expect function. So we're going to dig into that in a little more detail. This is just a quick overview, so don't panic if that's totally crazy sounding. It will make sense by the time we wrap up today, but just know that this is the final part of our test, or this is the actual test that's taking place. We're saying we expect this thing to have happened X amount of times, and that's our test. So we're just trying to say, okay, we know that our code is working to some extent if this function was called 1 time. So now that we understand the basic structure of our integration test and what's happening here, what I want to do is step back a little bit to our update user.js action and take a look at what we're trying to test. So there's a lot of stuff going on in this action, so we're not going to do 100% coverage in terms of testing this. And by coverage, what I mean is we're not going to test every single function to the nth degree inside of our integration test. So for this video, we're just going to test 2 things. So what we're going to do is we're going to test that update user password here and update user roles here are being called. We're going to do those as 2 separate tests. And again, because we're writing our tests as a suite, so we're saying describe update user.js. So this is the suite, and then these are the individual tests. We can still run those 2 tests. So again, for updating the user password and updating the user roles, we can run those tests separately, but we can also run them together. So we know that they're related, but we don't have to write all of the test code to verify that they were called together. We can write that verification code separately, but run all of it together. And again, once we run this, you'll see what I mean by grouping them together. It's not really grouping them in any significant way, it's just making it more logical for us as the developers to understand, oh, okay, update user password and update user roles are 2 functions a part of the code that I'm writing my integration test for, or in this case, the update user action. So what we're going to do is look here at the actual main body, or the main function that's exported from this file. So this is, technically speaking, the action caller function in our code. And if we look here, there's a lot of different things going on. One of the things that's happening is very first when options, so options is just a generic object of literally options, different things that we're going to need, different pieces of data that we're going to need inside of our action to do our work. So all validate options is doing is it's saying, hey, let me make sure that those things exist. And we can see it's very light in terms of validation. It's saying, if this thing doesn't exist, throw an error so that we as the developers know, hey, you screwed up, you need to make sure this thing is passed. So that's very light in terms of what it's doing. but very helpful. So it makes sure that when we run our code, we know whether or not we're using it in the way that we intended or the way that we designed it. So that's step one. And now step two is, okay, we need to make sure that the person performing this action is actually authorized. And we're not going to go into too much detail about this check if authorized function, but what I would recommend is hopping over to the pup documentation and making sure that you kind of dig into what that is, because there's a few moving parts to it. But what we want to know here is that we're checking to make sure that is the user performing this update actually allowed to perform the update. And if we look here, this error message that will fire if that's not the case kind of tells us what's happening. So we're saying, okay, you either need to be an admin user or you need to be the current user that's being updated. And what we mean by that is, again, you can call this update user action either from the admin panel. So if you're an administrator and you want to update a user, you're going to be able to call this function. So we need to validate, are you an admin user? Or you can call the update user action from your profile as a user of the application. So if I'm a user of the application and I make a change, I should also be the current user ID that's logged into the application. So we're trying to get an either or verification on that. We either want the current user to be an admin or we want the current user's ID to match the ID of the user that we're trying to perform the update on. And then we actually get into the work of the module. So these two are just kind of validating things and checking that everything's okay. But then down here we actually get into the work of the action and what it's doing. And this is what we're trying to test. So if we look specifically on 85 and 86 here, we can see that we're saying if user to update dot password. And if we look, user to update here is us just giving a name to the options.user object. And so in this case, what we expect options.user to be is a collection of changes to the user. So we're saying this is the user object and these are the changes that we want to make. So if I spec this out real quick, it would look something like, so we'd have options and then we'd have user on options. And then in this case, if we look here, we're expecting things like password and roles. So in this case, we're expecting to change the password to 1, 2, 3, 4, 5, 6, or we're expecting to change the roles to doodle and and boop. So that's all that's happening there. And when we put it behind a variable, that's just to give it a better name than options.user so we know what data we're playing with. And so if we look, we're saying user to update.password, or if user to update.password, call the update user password function. So this is very modular in terms of its behavior. So we're not just calling all of these functions no matter what. We're only trying to call them if that data is passed to us. So it's trying to be as efficient as possible and say, if this data is actually passed to be updated, try and perform the update. So in this case, we're saying if user update.password is given to us, or it's passed on the options.user object, call the update user password function and pass in that entire user to update object. And then if we go up to that function, we can see, okay, we expect an object. So here we're using JavaScript destructuring to say we want to pluck off the ID and pluck off the password from the object that we're passing as the argument here. So if we look back down here, we're passing user to update the entire user object. And then up here we're saying, okay, we've got that object and we're plucking it apart, or we're destructuring it. So instead of just having a variable here like user, we can just say, okay, give us the ID and the password. And then we can see all we're doing inside of this function, update user password, is calling to accounts.setPassword. And so this is what we're trying to test. So if we jump back over to update user.test.js here, what we can see is that we're calling expect accounts.setPassword to have been called ×1. So what we need to do is wrap our heads around, well, why are we doing that and how is all of this actually working? So if you remember from our unit testing video, when it comes to our test, we actually need to fire or run some code first in order to verify that it actually worked. And if we look right here, what we're doing is exactly that. So up top here, I've imported the update user action And because that's in the same exact directory, I can just say /update user, and here the .js is implied, so I don't need to type that out. It's just implied by JavaScript. It assumes that it's going to be a JavaScript file if we don't specify. So we're importing that function here, and then we're calling it inside of our test. And if we jump ahead just a little bit, you'll notice that we're also calling it inside of this test down here. And we're going to ignore that test for now, but the point I'm trying to make is that for each test that we're writing, we're going to call the function that we're trying to test, or call, in this case, the action that we're trying to test, passing it some different values or some different parameters. Or if we look back here, some different options that we pass in here and then we validate here. So we're trying to see, given these arguments or given these options, does our code behave in the way that we expect it to? And so in this case, we're saying the user's password is updated as our test. And in order for this to work, what we need to do is say call update user, and we're going to pass it some data. Now here, this data isn't real. You'll notice that what I'm doing is I'm just saying current user underscore ID is ABC123 and password is super secret password. So the point here isn't to pass this real data and verify that that does what we expect. So you may have seen some tests or heard about tests where you actually test that data makes it to the database. We don't really care about that because that's not our responsibility. So what I'm talking about here is the boundaries of our test. Like, what are we actually trying to test here? And all that we care is if the update user function is called, does it attempt or does it try to set the user's password? Because that tells us that, okay, as long as the accounts.setPassword function does its job, or it's behaving in the way that the developers of that function expect, then all should be well as long as it's called. And we can see here, we expect it to have been called with certain arguments. So that's jumping ahead a little bit. Let's focus back up here. So what we're going to say is update user, passing these options. And we can see here current user is on that options object and user is. And if we jump back over to update user, the reason why is very specific. So one reason is that options.user here is going to map to the user object here. So that's one. We need to make sure that that exists because we can see that our code is dependent on that existing. So we need that to be in there. And it's dependent because if we look up here, options.user needs to be there or our code is going to throw an error. So we have to pass that no matter what. And we can also see that current user is necessary on options. And so in this case, we're saying current user here, and we're giving an ID of ABC123. So we don't really care who the user is or anything like that. We just want to make sure that, okay, there is a current user being passed as far as this update user action is concerned, and that there's a user pass. That's all we really care about here. And with this in mind, if we go back over to update user.js, we can see that the reason we only care about that is right here. So we're saying if user to update.password exists, so user to update again is user here, and this is the hint. So password here has significance. So we're saying if user to update.password exists, we want to call to update user password. So in this case, we expect that our code is going to call to update user password, which then calls to accounts.setPassword. And so, in other words, if we go back to our test, what we're saying is the user's password is updated as long as, and now if we look here, we expect accounts.setPassword to have been called times 1. So quite literally, our code is working if accounts.setPassword is called. And that's true because we're saying call that function if user to update.password is called. And so we say update user password. And again, that's just a wrapper to set some context around what this code is doing. So if it fails, we know that, okay, it's this code that's failing. Whereas if we called this by itself, we'd be at the mercy of the developers of that code to make sure that an error that was intelligible to us was actually passed, which, as we've all learned in the JavaScript community, is very rare. So this is guaranteeing that, okay, we at least know where the error is occurring, and then we can debug it a little bit faster. So in this case, we're making sure that, okay, accounts.setPassword is being called by the update user action. And so let me make sure I didn't cause too much chaos here. Let's back up just a little bit. And there we go. So our file state's good. And if we jump back to our test now, this should be starting to make a little bit of sense. So what we're saying is call update user and then verify that this happened. So accounts.setPassword was called 1 time. So if we think about this, technically speaking, this test, or rather this function that's performing the test for us, is creating its own little world. So when we run the test, or when this test is called, it's calling update user, and then even after it's done that, we're still inside of the test when we get down to these expect statements. So what we're effectively saying is, okay, in this current universe, having called update user with these options, we would expect that accounts.setPassword would have been called 1 time, and we also would have expected it to have been called with these parameters. So if we look here, ABC123 matches the current user, and super secret password here matches the password. And if we look, again, we're expecting accounts.setPassword to have been called with those 2 things. Now if we go back to our code and look, the reason why is if we come back down here, and we got to be very careful. So if we look at this line, we're saying if user to update and not user to update _ID, we want to overwrite it with the current user's ID. So in this case, if we go back here, we're not passing an ID for our user. So user to update.id doesn't have a user ID. And if we read this note, it's basically saying that, okay, if we don't have a user to update.id, that means we're trying to make changes to the current user. And so this code here is just assigning the current user's ID. Again, options, this object that we're passing here, and the current user property and the ID property of that current user object, we're assigning that back to the user that we're trying to perform the update on. And so by the time that we get down to this line, and we say user to update.password, so if the password exists, pass the entire user to update object. And so by this point, we would have expected our code to have assigned the current user ID back to the ID of the user we're trying to update. So basically, we're trying to move this ID down to here. We expect our code to do that for us. We shouldn't have to do it. Just by virtue of passing those options, we expect our code to do that move for us. And so if we come back here to user to update being passed to update user password, and then go up to that function, we can see that we expect the ID on user to update, which again is set right here. So we're saying user to update.id is going to be equal to the current user ID that we're passing right here. And that's just by virtue of this code. So if we would have passed user to update.id directly, meaning if we would have had ID ABC123 here, this if statement would never have run. But we're not concerned about that. We just want to verify that, hey, this is working as expected, meaning if we don't pass an ID directly for the user, does it reassign it from here? So with all of that assumed or in mind, if we come back up here then, we would expect ID here to be ABC123 and password to be super secret password. And so if we keep that in mind and go back to our test, we can see, okay, count set password to have been called with ABC123 and super secret password. Now, this is where integration testing gets pretty interesting, because up until this point, we haven't really explained how accounts.setPassword got here. So if you look, we're not passing this as a string. We're actually passing accounts.setPassword. So if we look at the top of our test file, we can see that we're importing the accounts object from the Meteor accounts base package. Now this is fine, but this presents an interesting problem when it comes to writing and running integration tests, which is context and scope. So when we run this test, what we don't want to do is actually call the accounts.setPassword function. And the reason why is that even though this isn't the case, if there was a user in our database called ABC123, or they had the ID of ABC123, we don't want to change their password to super secret password. We just want to verify that that function is called without actually calling it. And so the way that that works is through something called mocks. So in testing, a mock is just a fake version of a function in your code. So in Jest, there's a few different ways to write mocks, and just as a hint, we'll come back to this one, but you can see that up here we're saying jest.mock, or there's another way to do it. So over here I've got accounts.base or accounts-base.js, and we can see that this is in the tests, and this test directory is at the root of pup, or at the root of our application, and we're saying the test folder, and then we've got _mocks_, a directory called Meteor, and then we have accounts-base.js. And if we look inside of that file, what's going on here is we're exporting, we're going old school required JS modules. We're saying module.exports equals, and then we're passing an object with a structure that looks like what we'd expect the accounts variable that we're importing up here to look like. So again, we're saying accounts.setPassword down here. We import capital A accounts up here. So back here, what we're doing is we're creating a mock of that module or of that function. So in this case, the accounts package in Meteor, we're trying to mock that because again, we don't actually want to call accounts.setPassword when we run our test. We just want to verify that that code was called. And so a neat feature of Jest, which is again the library that we use to write and run our tests, is that it gives us a great piece of functionality for mocking our code called jest.fn or jest.function. And so what this is doing is it's creating a fake function that we can assign back to some code in our application. And then when we run our test and we say, hey, we expect this thing to have been called, Jest knows that it expects one of its jest.fn functions to have been called. And so that's the verification that our code is working as expected. So if we think back through that, what we're effectively saying here is create a fake version of accounts, and specifically the setPassword function in that accounts package. So again, we're not modifying the code of the accounts package. We're just creating an assumed version of it, or an assumed fake version of it, for the sake of our test. So again, we're not modifying the actual accounts package at all. We're basically, this would be like somebody being a copycat. So maybe they look at the accounts package code and try and write their own version of it, and they copy some of the structure of it and things like that. We're effectively doing that, but the way, or the reason that we're doing it is so that we can fake call that code inside of our test. So we're not actually trying to copy the code for the sake of running it. We're just calling the code for the sake of testing that it's called. And that's one of those things I highly recommend rewinding the last minute or so there and listening to that again, because it's very heady trying to wrap your head around what's happening here. But keep in mind that all we're doing is creating a fake version of the accounts.setPassword method here. And by setting setPassword to jest.fn, we're communicating back to Jest, or eventually we will communicate back to Jest that, hey, this is just a fake function that we want you to call, but we don't expect it to actually do anything. So if we look here, this is the part that needs to be demystified a bit, which is we have this test directory with _mocks, and then we have this Meteor directory, and you'll notice that accounts.base.js is here, and this is something that I've added specifically for this tutorial, but we've got a bunch of other files in here. So these are different packages that are used inside of pup, or different Meteor packages that are used inside of pup. And what I've done here is I've mocked out each of these packages. Now, these won't come into play with what we're working on tonight. This is just kind of making a general point that whenever you have some code that you're going to try and test inside of your test, and you don't want to actually call that code, you're going to have to write a mock. And so what we're doing here is we're mocking out Meteor specific packages. And so if we jump down here, so I'm still at the root of the project, and I'm going to open jest.config.js. If we look in here, what we've got is just a bunch of configuration or settings for Jest. So when it runs, it's going to look at this and it's going to say, okay, how do I behave, or how do I do my job? And if we look at the top here, we've got this module paths property on the Jest config.js options object. And that module's path, or module paths, it's kind of hard to say, module paths property is set to an array with a couple of different things. So we can see it's passed 2 strings, each with a this funky root dir, or root directory. I guess you'd call it a variable. It's not really a variable, but that's the way Jest reads it. So we're saying root directory slash, and then node underscore modules, and slash tests slash double underscore mocks double underscore. And so what these are doing is these are saying, hey Jest, here's where you can resolve mocks of or fake versions of either npm modules, so in node modules, or Meteor modules here in test slash mocks. And this will also contain npm modules. So these are kind of replicating each other. So this one is covering custom npm mocks that we're writing along with Meteor mocks that we're writing. And this one is just saying, hey, these are where our node modules are at. And that's because Jest has an auto mocking feature that we can utilize depending on the type of code that we're calling. That's one that I'm not personally super experienced with, but when I've used it, it's one of those magical things. You do it and you're like, oh, this is neat. So that's what that's doing, is it's basically just telling Jest, hey, here's where our module code is that we're gonna try and write mocks for. And so if we come back down here and we look under module name mapper, we've got a bunch of different stuff going on, but the one we want to pay attention to is this one. So this is saying, hey Jest, when you see an import, so if we go back to update user here, when you see one of these, so an import, or I should highlight this one since that's what we're focused on. So when we see an import like this, where we have Meteor slash some name, in order to resolve that, what we want you to do is say, take the first value before the colon and the last value after the colon and map that to this path. So we're saying we would expect that module, so in this case the Meteor package, so let's go back to update user. We would expect accounts-base or Meteor slash accounts-base to resolve to a file in slash test slash double underscore mocks double underscore slash Meteor slash, and then this is where it gets funky. So we're saying $1 underscore $2. And what this is doing is it's resolving Meteor mocks. And the reason that it's doing this is because Meteor is pretty unique in that it has its own package system, but it also has its own syntax for defining the actual package names. So if we look at this one, so accounts base is one that's built into Meteor, so that one's not too funky. But if we look at the one just below it, which is something that we're going to need to test in a little bit here, we can see that it's got an author name colon package name. And so what this is doing in Jest config is it's saying take the author name colon package name and map it to this path. So author name underscore package name. So if we look back in our test directory, specifically that A landing roles package, what we're doing is we're mapping A landing to where the $1 is and roles to the $2 variable right here. And the reason we need to do that is a little strange. So in Mac OS or Unix operating systems, and don't hold me to this, I'm pretty sure this is correct, but in Mac OS operating systems, you're allowed to have a colon inside of your file names, whereas other operating systems like Windows don't allow you to do that. So what we're doing here is effectively making this code safe for all operating systems, because any operating system is going to be fine with an underscore being in your file name, but a colon might cause some trouble. And because we can't change how Meteor itself behaves, we have to tell our test code, or we have to tell Jest, hey, we have to work around this, so make sure to map the name of your Meteor modules to this syntax, and we can see that that's trying to resolve to a JavaScript file under tests _mocks /meteor, and then following that pattern of author name _ package name, we expect a JS file to match that pattern inside of this directory. So this is probably a good point, if you haven't already, to be asking, what in the hell is going on here? And that's a fair question, because this is pretty confusing the first few times that you work on it. So with all of this in mind, we have this concept of mocks. I'm going to go ahead and close this out. We have this concept of mock functions that are fake functions that our test code is going to call in place of those actual functions. So if we jump back here to our update user action, so our actual code that we're trying to test, if we look in here, we're saying, okay, call update user, and in this case, if there's a password pass, call update user password, and then come up here and say accounts.setPassword, call that. So all we're doing inside of our test with that mock is we're saying, call this code, and remember that this function, or rather this test, is its own little world. So when this update user action is executed in this little world, and more specifically this test file is executed by Jest, Jest is going to see, hey, do I have a mock for this code? And again, that's going to follow that pattern we just looked at. So it's going to say, do I have a mock for this? Oh, I do. Okay. So when we get to this point, it's going to say, okay, let me see if accounts.setPassword was called by update user. And so when update user runs, what's going to happen is update user is actually going to call accounts.setPassword, but in the context of our test, Jest is already going to have loaded our mock from back over here in accounts.base.js, so it's going to have loaded that mock. And when it gets to that point in the update user code, so when it calls this, technically speaking, because we're executing update user inside of our test code, or that special little world that's controlled by Jest, it's going to say, you know what? When you get to that point, let me swap out that function. I'm not actually going to call the real account set password. I'm going to call the mocked version that you've provided for me. And so what happens is when we get to this point in our code and we run this, what's going to happen is we're going to call the fake version. So effectively when we say accounts.setPassword here, we're saying just.fn or just.function. And so we're going to expect that code to have been reached and called 1 times. And we also expect that it's going to have been called with ABC123 and super secret password. And that's what we walked through earlier. So that's based on the options that we're throwing here. So if we save this and then jump over to our terminal, we can see that all of our tests are running. So what I'm going to do is pull up the, I think it's O is what we're after. Yeah. So we can see update user.test.js is passing. So we have 1 passing test suite with 2 passing tests. Now, if we call this, and well, let's just muck this up to make it fail. So I'm going to say I expect this to have been called 3 times. And we can see when that test runs, well, no, it wasn't called 3 times, it was called 1 time. And so that's telling us that, hey, all right, this is working. And that's great. So effectively what we've done with all of that thinking and all of that work is we've verified that, okay, update user at the very least is getting to the point correctly where it needs to update the user's password given that we passed the correct parameters. Now, depending on how thorough you want to be with your tests, that's going to dictate the different permutations that you write of this test. So this one is very simple. So I wouldn't say that this is a foolproof test or bulletproof test in this case, because we're only saying, hey, did account set password get called? Which it's working, but it's not really verifying a lot. So if we were going to be writing this for a production piece of software, we might want to try some different things like, okay, so this is what we would call the happy path. So if we pass everything exactly as we'd expect, does it work? It does, Great. Okay, that's one test, but we also want to test things like, all right, what happens if that contractor we just hired, passes the wrong data or misspells something? So maybe they call it users, or, instead of current user, they just say current. And that doesn't work. We want to verify that our code is fault tolerant. And so in order to do that, we have to write tests that test that threshold of fault tolerance. And so that's just the responsibility of us as developers. We have to build out robust test suites to make sure that all of these different ways that we think our code might be used is being tested properly. And so that's one test. Again, that's the happy path. That's the simple test, but hopefully that's enough information for you to wrap your head around what does it mean to write an integration test. So here we've tested one part that we can set a password, but down here we've got another one, and this looks very, very similar. So this is saying we want to verify that the user's roles are updated as well. And so you can see here, we're still calling update user, and we're still verifying that roles set user roles are not. Still, I should say, we're calling another mocked function. So if we look at roles set user roles here, again, we import the function up here, but again, when this code runs, it's going to try and resolve to the mocked version of it. So if we jump back down here to test, we can see a landing roles is mocked, and specifically the set user roles function that we're using inside of update user. If we look right here, we're saying roles.setUserRoles. That's already been mocked as a part of pup, so we don't have to write that again or write that specifically for this tutorial. So that's taken care of for us. So again, when Jest runs our test, it's going to say, okay, let me check for the mocked version of that. It's going to get it, and it's going to say, I expect that to have been called ×1, and I expect it to have been called with ABC123, so our current user ID, and I expect it to match the roles that we've passed in as well. So we should be trying to set these roles on the user. And so in terms of how that's behaving, these two tests are functionally identical. They're testing different code, but they're essentially doing the exact same thing. And so that's great, but something is kind of hiding in the bushes here that we can't really see. And so if we go back up here, you may have been wondering what's going on with this jest.mock check if authorized JS and this whole isadmin mock implementation thing. And so what this is doing is it's handling a piece of code in our code that we're testing behaving in a funky way. So what I mean by that is if we go back to update user.js and we look down here, we're saying if user to update.roles is passed, and this is where this gets funky, is admin. So if the current user ID is an admin, go ahead and update user roles. And so this is good in the fact that our code is trying to be secure. It's saying, hey, you need to be an admin to change the user's roles. So in other words, a user can't change their own roles. And so this is all well and good, but when we run our test, isadmin needs to be resolved. And again, we don't want to call this isadmin function directly. So that's coming from this check if authorized module here. So if we pull up check if authorized JS here, we can see that it exports a function called isadmin, which calls to roles user is in role with the user ID and checking to see if they're an admin. And so if we go back over here, remember when we call our code, that's going to be called. And so just like we saw with the accounts package here and the roles package here, we need to mock that code out because we don't want to actually call it. And the reason we don't want to call it isn't because it's going to do something destructive, but because we can guarantee it's going to fail because the user with ABC123 doesn't actually exist. That's not a real user, which means that they're not going to have the role admin like our code requires. And so what we can do is we can be a little bit sneaky with our mocking and say like, well, why don't we mock that code, but we make it do what we want, just so we can get past this. Because again, we're not trying to test that isadmin is working. That's not the scope of this test that we're writing right now. We're only trying to test that roles set user roles has been called and it's been called with specific data. And so what we can do is work around that and say call to jest.mock, and this is that auto mocking feature that I talked about earlier. And again, this is one of those things that's still a bit of a black box to me, a little bit magical, but it does work. And so what we're saying is call jest.mock, and we pass it the path to a module that we want it to mock. So in this case, in the same directory as this update user test.js file, we have check if authorized JS, which again is exporting that. Let's go back here. So it's exporting this isAdmin function that our update user code is calling. And so what we want to do in here is we want to mock that specific code, and then down here we're doing something really neat. So what we're saying is we want to change the mock implementation of isAdmin to do something specific. So generally speaking, when it comes to mocks, you're going to do what we saw over here where you write your mock file and you resolve it specific to a package, but sometimes you have code that's application specific. So it's not a package or third-party package that you depend on, but it's code in your application that you depend on that you want to fake the behavior of. So in this case, that's what we're doing. We're saying we want to mock this isAdmin function. So in order to do that, we import it as usual, but when Jest gets to this point, it's going to say, oh, hey, wait a minute, I need to mock this function. So it's going to see that being called, and it's going to say, let me mock that up. And then when we actually get the mock done, so it's going to mock out the code in there if it can, what we want to do is modify the implementation, or the mock implementation of the isAdmin function. And if we look here, what we're saying is isAdmin.mock implementation, and then we pass a function. And so what this is doing is it's overriding the behavior of the mock entirely. So this function here is equivalent to a jest.fn like we saw earlier, but the difference is that we're just saying do this instead. So instead of just calling jest.fn as kind of a black box function, what this is doing is calling this function and behaving in the way that we force it to. So here what we're saying is we always want isAdmin to return true. So we're not going to actually validate that the user is an admin because we don't care. We're just saying, hey, go ahead and return true. So that way down here, when we call update user, we're going to, again, pass the user with a roles array. And if we come back to update user and look at our code, when we get to this level or get to this step, we're going to say user.update.roles and isAdmin. Now when isAdmin is called, we're going to use the mocked version that we wrote at the top of our file here, which is just going to return true. So in other words, this is going to say user.update.roles exists, true, and we know that's true because we're passing roles right here, so that box is ticked. And then we're saying and the current user is an admin. And again, we don't care whether they are or not, so our mock up here is just going to return true. And so back here, when this code is executed, again, this is being executed in this special little world of this test. So when that code is executed, what it's going to do is it's just going to return true. So we should get true and true, which means that update user roles is called, which means that up here roles.setUserRoles is called. And so that way we can move forward with our test verification and see, was roles.setUserRoles called, and was it called with the user ID and the roles array that we passed for our options here. So that, in sum total, is integration testing. What we're doing is we're checking to see, do various parts of our application or various chunks of code in our application behave well together. And so in this case, calling update user, which is calling to a lot of different pieces of code, we're trying to verify, hey, is that working how we'd expect? And so now what we can do is if we jump back over to our terminal here, okay, we've got a problem. So this is in the, and you'll notice that if we have a problem, we can always look and see. So this is saying update user.js test suite. The user's password is updated test, which is a little strange because we didn't do anything to that. What would be going wrong here? So our example from earlier, we had modified it to pick on the hypothetical contractor that would have broken our tests. So now we're the hypothetical contractor breaking tests. So we passed the incorrect variable name. So technically, our code was working because it failed when we passed the incorrect data. So it didn't do what we expected to do. So that's great. Now we've got our test passing. So with that, now we've figured out how integration tests work. So that's going to wrap it up for this Feature Friday. I really appreciate you watching and hanging in there through this. I know these sorts of topics they can be kind of bland and honestly fairly confusing, but this is the sort of stuff that's super, super important for you to wrap your head around and start to utilize in your own products if you want to move towards being a more professional or serious developer. And so what I mean by that, just to wrap up with a little story here. So over the past few years, I've been aware of testing, but I haven't really done it myself, and not at an extreme level. So if I've done any testing, it's been very micro stuff that I did understand. Like I understood how to write unit tests, and I kind of understood these integration tests, not really, so I didn't write many of them. And then I also understood what we're going to talk about next week, which is end-to-end tests. But it wasn't enough understanding where I was very consistent with it. And what that resulted in was me constantly writing code that would work most of the time, but not all of the time. So my code wasn't terribly consistent. And because I run a business that's reliant on that code, that's very problematic. So there were a number of times over the last few years where I would write code to do something for my business, like charge a customer's credit card, or in the case of the mentorship programs that we have at Clever Beagle, I have a credit system. So each month a mentee gets a set of credits for appointments. And I would have credit systems that would update the credits whenever a customer's subscription renewed. I had things like that that would just randomly break because I didn't test to see if, oh, well, what happens if we add a user manually to the database, but then we forget to set their credit card last 4 digits? Does the code still work? And these granular details kept breaking my code, and I couldn't figure out why, until I said, finally, okay, let me just sit down with testing and try and wrap my head around what it is, how it works, and why it's important. And I can say without a doubt, as I've progressed, and this has just been over the last handful of months here, but as I progressed with this stuff and I've started to work with it more and more and integrate it into my own workflow, I can tell you, as I guess you could call me a veteran at this point. It's been right around a decade I've been doing this stuff. If I could choose to start again and learn testing up front and use testing in my code versus not, I would choose testing 100%, because it just lets you sleep well at night. And if you're a developer, you've definitely at least once had the night sweats about some code that you've written not working in production. And so all I can say is, though there are a lot of steps involved in this, there are a lot of moving parts, that's kind of the price of entry, so to speak, for being a professional developer. So if you're very serious about writing not just nice applications, but nice applications that work, it's very worth you investing the time in learning how to write tests. So again, we're going over very simplified versions of testing in the last 2 videos, and as well as the 3rd video for next Feature Friday. But even with that, take that information and really start to play with this, because it's the type of stuff that's going to help you grow as a developer and become more trustworthy. So whether you're running your own business and you need the code behind your business to be more trustworthy, or you're working in a job and you're building code for a company, that code is going to be more trustworthy. And the pot of gold at the end of this is quite literally, the better and more stable your code is, and the more consistently you can produce code like that, the more valuable you are. So that's going to make you more valuable to certain companies, where you can walk in the door, and if you can show that you can do this stuff and you can write your code in a very consistent way that always works, oh boy, how are you going to be paid well. So don't think that this stuff is just geekery and you're just playing around. So if you really want to level up in your career or level up your business, this is a great way to do it. And it's one of those things that if you invest the time into it and you really get a system down for yourself, it's really going to help you move forward. So hopefully that little tidbit information kind of sinks in with some of you folks watching this and you take that and you can do something really great with your career and what you're trying to do in life. So with that, that's going to do it for Feature Friday. Again, I really appreciate you watching. If you haven't already, make sure on our YouTube channel to go ahead and hit the subscribe button so that you get all of these new episodes as soon as they're released, and also click the bell. So if you want like up to the minute notifications on when these go live, make sure to hit the bell as well. And thank you for watching, and again, next week we'll be digging into end-to-end tests. If you enjoyed this tutorial, I'd really appreciate it if you head over to cleverbeagle.com/subscribe and sign up to get our latest tutorials and advice in your inbox as soon as they're published.